Hi class, there's been a request for solving question 8 on REQ 15, which is from section 6.2. If you do not want to see the solution worked out and want to work it first, then you should pause this video. All right, let's go. The very first thing we should do is use the distributive property to distribute that 1/5 to both terms inside the parentheses. If we do that, we're going to end up multiplying 1/5 times 3, which naturally has a denominator of 1 if it doesn't have any denominator at all. To multiply fractions, we multiply across, which would give us 3 over 5. So we get 3/5 x. Doing that again for the 2, 1/5 times 2 over 1 equals 2/5. So we get plus 2/5 equals 7/2 plus x. Now at this point we have a couple options. You can get all the x's together by subtract an x over, subtract 2/5. I don't know if they've mentioned this before, but another option is to multiply by the LCD, or the least common denominator. That will allow us to get rid of the fractions kind of earlier in the problem. I know that if we have a choice, we'd rather have whole numbers than fractions, and if we have some control, that's fine. Our common denominators, technically we have a 5, a 2, and a denominator. It's kind of implied, but there's a 1. So a multiple of 2, 5, and 1 at the same time, at the very least, is 10. So if we decided to multiply all numbers by that least common denominator, we would have 10 times 3/5 x. Now keep in mind, what you do to one, you have to do to all of them, to both sides of the equation. So we have 10 times 3/5 x plus 10 times 2/5 plus, equals 10 times 7/2 plus 10 times that x. All right, so here again the denominator is implied to be 1. So if I get common denominator, I get 30 over 5, which is 6. Because it is a least common denominator, we are guaranteed to have whole values there. It's not a surprise. It shouldn't be a surprise. It is consistently going to be the case if you have multiplied everything by the least common denominator. Okay, and then here we've got again 10 over 1, which is 20 over 5, with plus 4. And then once more 70 over 2, which is 35, plus 10x. All right, take a look at that. I'm going to pause the video to clean my board. All right, to finish the problem, we have 1, 2, 3, 4 terms, only 2 of which have an x in them, the 10x and the 6x. We have to do opposite operations in order to get them together. We can move everything, all the values with an x to the left or all the values to the right. Personally, I like to do the smallest value that's got an x on it, which would be the 6x. So the opposite operation would be to subtract by that piece, since we were adding by that piece. We get 4 equals 35. 10x minus 4x, or 10x minus 6x is 4x. Getting the x by itself, 35 is hindering the 4x from being by itself. Opposite operation, again, is subtraction in this case. Okay, 4 minus 35. Keep in mind that the signs are opposite. We've got a positive 4 and a negative 35, so we are going to subtract and take the sign of the larger. So subtraction would say 31, sign of the larger would be 35, which was negative. Final piece, we would get x by itself. Right now it's being multiplied. The opposite operation would be division. So dividing by 4 on both sides, our final answer should be x equals negative 31 over 4.